So Kim, what do we have in our Trust Your Science inbox today?
Yep. So we actually have a really good question. I'm not quite sure how we're going to handle. They're asking about the TCA cycle, or citric acid cycle. It's also known as the Krebs cycle.
Huh.
And they're asking if there's an easy way to do this. Actually, they're kind of challenging us. Is there an easy way to do this?
Yeah, I don't know much about TCA cycle. I mean, I know about tricycles, bicycles, popsicles, but I don't know.
Different, not sickles, cycles.
We need to find somebody.
I think we do, because, you know, the only methods I've seen, there's no really simple way to do this. You have to do derivatization. You have to use complicated mobile phases. I think we're out of our league. I think we need the special apps team.
I do too. Who do you think would be perfect for this one?
Carrie. Let's go find her.
Yeah. Hey, we found Carrie.
Carrie, I am so glad we found you. You were the only person we could think of to help with this question. We actually have a question from a customer who's asking, kind of challenging us, if there's a simple way to do the TCA cycle.
Oh, guys, good question, because this is something that I've actually been working on in the lab. And if I could show you some of my data, I would love to do that.
That would be fantastic.
Perfect.
Carrie, can you even tell us what the TCA cycle is?
Oh, sure. So the TCA cycle produces precursors for amino acid, protein, fatty acid, cholesterol, and nucleotide synthesis for cell growth and division, and it also represents a key component of homeostasis. The proportions of these analytes that are present in the TCA cycle can change in response to certain diseases. So what we'll typically do is measure these analytes and look into them and see if we could find insights into the mechanisms of diseases and disorders.
Ah,
that's cool.
So one of the challenges with this assay is really the analytes themselves. So for instance, citric acid and isocitric acid are isobaric. In fact, they also have the same fragment ion of 111 m/z. Malic acid has an m/z of 133, but fragmentation followed by decomposition in the collision cell, it gives rise to the same MRM transition as fumaric acid. So to address the separation and retention of these critical pairs and the other varipolar species of the TCA metabolites, a mixed mode chromatography method was developed.
Carrie, that sounds complicated.
Actually, Kim, it's not that complicated at all. By using a CSH phenylhexyl column and a very simple mobile phase of water, acetonitrile, and a little bit of formic acid, we're able to separate all of the major analytes in under 3 minutes.
Awesome.
That's cool. So Carrie, a lot of people worry about the reproducibility of these types of assays. How's the reproducibility of this one?
Well, the reproducibility is actually really good. So what I did is I ordered a method validation kit that has 3 different lots of the CSH phenylhexyl material, and then I ran my method. And looking at the reproducibility of the retention times, they're all under 1.25%, and that's very acceptable.
Yeah, that's really good.
Phenomenal. All right, Carrie, so everything we looked at was neat standards. You know, everybody always wants to know, what does it look like with a real sample?
We tested the separation in this method in urine. So what I did is I took a urine sample and I just diluted it 10 times with water, injected it on the column, and here's my results.
So it really does work.
It really works.
That looks really good. So I was really glad we were able to get Carrie in here, work her magic, and really drop some knowledge on us. Thank you so much.
Special apps always comes through. So you did some amazing work. And I think you showed that this actually did work. So how do you want to call this?
Oh, it's busted.
Busted!
So with the work you did, I mean, the challenge really was, is there a simple way to do this? And I think you showed with the simple mobile phase using acetonitrile, water, 0.1% formic acid, you can do it.
Absolutely.
With real samples. Would you do us the honors in writing this up?
I would love to.
Aw, thanks, Carrie.
Thanks, guys.
If you'd like your question to be answered on a future episode, please feel free to email us at trustyourscience@waters.com.